So I want to start today with just asking you, part of the journey over the last while has been building skills and strategies to solve equations. And I want to just ask in the chat or over the Zoom, what are some of the strategies or things we need to do when we solve an equation, or what are some of the steps we have to do? And I just want to do a quick little bit of revision at the beginning of the lesson. And if you can put something in the chat would be awesome. If you can put your hand up and tell us, that would be awesome too. So let's just start with a bit of revision. Okay. Who has some skills and strategies to solve equations? Pop your hand up if you got an idea, or you can write in the chat if you...
Brandon has his hand up.
Whose hand is up?
Brandon.
Brandon. Okay, Brandon, we're going to ask you to unmute, and you should see a little box pop up. Otherwise, is that box coming up? Okay, guys, if Brandon isn't working, I'm going to ask Kanyesile. And then if we could just keep the chat mostly. Okay, Kanyesile, I think you are live. What rules or what things come to mind?
BODMAS.
BODMAS. Okay, so you sometimes need to remember BODMAS when you're solving equations. Anything else? Anything else that comes to mind?
Hey, well done, girl.
Yeah. So what I'm going to say is that whenever you solve an equation, one of the things that you have to keep in mind is you have to get, we basically would say we isolate the variable, or we try and get the unknown by itself. And the fancy way of saying that is just to isolate the variable. So that's the one thing. So as an example, if I said to you a plus 3 is 7, in equations, what we want to do is we want to move this 3 around so that we can get the a all by itself, and because the a is the variable. So isolating the variable is one important idea. However, another strategy that I've been talking about a lot is how do we deal with the plus 3 in the simple equation? And we use something or we do something. What's the word that we use for that? So I'm going to go to Sipe Sichle.
So can you hear me?
I can hear you loud and clear.
So we use the inverse operation.
Yes, love it. Love
well
it.
done, Sipesile. Well done.
Could you tell us a little bit more about your inverse operation? So, like in this particular case, talk us through what it means to use the inverse operation.
So we divide both numbers by the I think so can I give an example?
Yes, please go ahead. Yeah.
My example is 2x plus 1, which is equals to 11.
Okay.
We'll divide that by 2.
Okay, but now I love your example, but I want to point out that when we are and you're on the right track with the dividing by 2, but something is catching my attention. What about this plus 1?
Oh, we do we minus 1.
Oh, okay. So first we need to minus 1. And why is it minus 1 you're choosing?
So because we have to use inverse operations.
Okay, and the inverse or the inverse operation of plus 1 is minus 1. And so what I'm going to do, Sipe is if I take away 1 from both sides, the left-hand side will become 2x and the right-hand side will become 10. Would you agree with me? Now,
yes,
did you notice how I was a little bit sneaky there? I didn't write the minus 1 on both sides, but I definitely did do it. Hey, you can see like I took away 1. Okay, now that's one of the things today we're going to start doing, where I'm going to say I do something, but then I'm not always going to write it, but everyone's going to see it. Okay, you've done perfectly well. Now tell me about the 2. What about the 2 here?
We divide 2x by 2, and we divide 10 by 2 as well.
Exactly. And so what would our final answer be?
5.
Perfect. Thank you so much. You have been so helpful, Sipa.
So
Well
Now,
done, girl. Well done.
what I want to say is not only, I actually did 2 things here. When I was dealing with Sipa's question, I didn't just take away 1. I took away 1 from both sides. When I looked at the inverse operation for 2x, I didn't just divide by 2 on the left-hand side, I divided by 2 on the right-hand side. And so I want to know, what is that rule or strategy that I use to solve my equation? Can anybody help me with that? What's it called when I don't just do the operation on one side, I don't want to give it away. Can anyone tell me? Give it a second there. It's the third, there's 3 golden rules for solving equations. The one is eventually you need to isolate the variable. To do that, you use inverse operations, but you also have to do something else. Otherwise, you break the system. We don't want to break things. Okay, Sipa, let's go.
So
Yep.
I'm doing something to both sides of equation to keep it equal.
Perfect. So do the same thing
People.
to both sides. Guys, this is awesome. We now have our cookbook to solve equations to matric. Honestly.
Woo!
Like, am I lying? Like,
No,
these
you're not
3
lying.
I'm not
These are
lying.
the goals. These are the
These are the-
points that we need.
Yeah.
Until matric, guys. How old
So
is this?
whenever we solve an equation, we have to get the variable by itself. If you look at this, x is 5, you'll notice at the very end, x is all by itself. And when that happens, it means that on the other side will be our answer. But there's 2 steps we have to go. We have to use inverse operations. Okay. And when we do those inverse operations, we have to make good choices. So for example, taking away 1 from both sides was a good choice. And then dividing by 2 on both sides was another good choice. Okay, so this is going to be, a lot of the lesson today will be around practicing that. But we need to add something else in from the previous module. And so I just want to add that very quickly. Now, what this is called is multiplying out brackets. So sometimes you get an equation where you have to multiply out the brackets. And I will show you an example here. So in example number 1, it's this one. In algebra, when there's a 2 in front of the bracket, it means it's multiplied. If we multiply the bracket out, then 2 times 3x will give me 6x. And when I multiply 2 by minus 2, I get minus 4. And so we say that these 2 expressions are equal to each other. They're equivalent. Now, this is really important because when we're solving equations, sometimes we have to break things apart. And so we have to master this technique. So what I want now is I want everybody to try and do these 5 questions. However, if students are confused about how to multiply out brackets, I want you to raise your hand and then we will do some. Okay, so over to you guys. Let's see the distribution skills flying. Okay. And then Kanyisile, I'm going to unmute you because you've got a question.
Is there 2 Kanyisile here? Oh, I'm just, it's the same.
Or they have 2, a phone and a.
I'm not sure.
Okay, so we're trying to unmute
It's
you.
on your other side, Kanyisile. Oh, wow. On the charts, people are already on. Yo, we are flying, guys. Fire.
Okay, so if you want, you can put all your answers at once, or you can put them in pieces. It's up to you guys. Okay, can you see it? I'm trying to unmute you.
There we go.
Oh, it almost worked. There we go. Can you hear me? Can you see it?
Yes, sir, I can.
What's your question or comment?
So I wanted to know how you got the the expanded notation.
Okay, so the first thing to realize is that when I'm multiplying out, the relationship between the 2 in front and the 3x minus 2 in the bracket is a multiplying relationship. So you first have to understand what it means. Like if two things are next to each other, like if I have like this, the 3 is being multiplied by the x plus 4. Now, in order to expand this, what I often do is I draw a little arrow. And so I go 2 times 3x. And to work out what 2 times 3x is, we would get a 6x.
Yes,
But
sir.
now I can't ignore the minus 2 because the 2 is being multiplied by the minus 2 as well. And then I get minus 4. Does that help a little bit?
Yes, sir.
Perfect. Cool.
Give it a try. Can you see, Leah? Let's go. Give it a try on your book so we can mark together.
Yeah. So we've got, oh, my pen is way too big at the moment. Let me just change its size. So pen, let's just make it 0.5. So we get 4a minus 12. And then I'll give you a bit more time for the other ones.
Is it possible for, I'm asking Teacher Peter if it's okay for a student to come tell us about question 2, if they done question 2.
Yes, I'd love some answers for question 2, if anyone's willing. Okay, let's go to Tando.
Hello, sir. Hello, everyone.
Tando, how's it going?
I'm fine, and you?
Very good, thank you. Tell me about the second one. What do you think the answer is?
The answer is 14 plus 2b.
I agree, because it's 2 times 7 is 14 and 2 times b is 2b.
Well
Could
done,
you
Tando.
as well? Tando, could you help us with 3?
Okay, sir. It's 5c plus 60.
Okay, so 5 times c is that, and 5 times 12 is indeed 60. Fantastic.
Woo!
Thank you, Tando.
Well
You've been
done, Tando.
awesome. Let's go to Koketso. Can you maybe help us with 4 and 5 or ask a question? There we go. Koketso,
Yes, sir.
how's it going?
Good, and you, sir?
Very good, very good. Have you got, can you help us with 4 or do you have a question?
So I can help you with 4, sir.
Let's do it. Let's do it.
So number 4 is 24d
So 24d, yeah,
minus 3d, sir.
indeed.
Woo! My people, well done.
Well done. And while we've got you here, what about 5? Can you do 5?
Yes, sir.
Okay, what's that going to be?
So it's 8e plus 72, sir.
Okay, and you obviously know your times tables because that was good. 8 times 9 is 72. Okay, so later in the lesson, we will see that we need the skill of multiplying out brackets. Let's do one other skill. Or in fact, for students who need to take a screenshot, I'm going to scroll down in a second. So just take your screenshot. And then I just want to practice one more thing before we get going with the equations.
Tatenda, is that a question or because if I answer, everything has been answered now. So you can lower your hand if you wanted to answer.
So one other thing I want to do today, guys, before we get into the equations is what's called collecting like terms. And so I'm going to show you what happens in the question 1. We're given 4 terms, and of these terms, 2 of them are like terms, or they belong to the same family. And then 2 of them are called constant terms, so those 2. And what we do in order to simplify is we add the like terms together. So 5x minus 2x is 3x, and 10 plus 5 is 15. And this is called simplifying using like terms. That's another thing that will be hidden inside equations sometimes. So I want you guys to do for me question 2, 3, and 4, where you collect like terms to write a simplified expression. Over to you guys. And then while you're working, I would love to answer questions if students have questions. Okay.
Let's go. I hope you were marking, right, guys? You were marking the last time and you did this. short. If it was faster, then you can compare your answers. Well done. Oh, I love this class. Yes, guys.
Yeah. There we go. I see all my students working hard. Sibongile, Pusiswe, Tembelichle. I see you working hard, guys. Well done.
Remember, it's time now for questions. Either you put writing there on the chat or you raise your hand.
Yeah. Let's have a look. I do like using my colorful pens to bring
It does. It does bring some life in it. Interesting. Thank you, Teacher Peter.
Pleasure. Pleasure.
We see those answers in the comments. Keep them coming. Ooh, nice.
There we go. Okay. So what do we have? We have 10x minus 2. So the answer for number 2 will be 10x minus 2.
Woo! Mark that one, guys. Mark it. Hope you
So-
got it right.
Because 12 of something minus 2 of something is 10x, and then 10 minus 8 is going to be, I lie, it's not going to be minus 2, it's going to be plus 2. Look at that. Ooh. So 10 take away 8 is plus 2, not minus 2.
Science over there, science.
I know. So just to emphasize that, guys, you've got 10 of something, you lose 8, you definitely still have 2 left over. You've got 12 of something, so 12x, take away 2x, you get 10x. Okay. Kuketso, to type exponents, we normally use a little, what's it, like a little upside down.
Like a cappy.
Copy, like this,
Yeah.
basically like that. So
Yeah.
this would mean 2 to the power of 3, if you wanted to. No. Okay, who can help me with question 3 or 4? I would love to hear from the students.
Ayanda. Ayanda's raised her hand up.
Okay, Ayanda, can you help us? Hi, Ayanda.
Hi. Sir. Hi. So I
What's
collected my. Oh, okay.
Which question are you? Yeah.
I can do number 3.
Okay, go ahead. Tell me what to do.
So 3x squared minus 2x squared
Yes.
is gonna give you x squared.
So x squared or 1x squared. Perfect. Yeah.
And then negative 4 plus
Yeah.
5 will give you negative 1.
Will it give you negative 1? Just let's have a quick check. So here's my number line. Here's negative 4. Here's 0. And remember,
Oh
you
no,
need to
1.
add 5. What do you get?
We get to 0.
Not, okay, let's go 1, 2, 3, 4. So I get 4 units to get to 0. But remember, I'm adding 5. So where will I
Oh,
got
okay.
1 more to go, don't I?
Yes, sir.
So what's that going to be?
We give you 1. Positive 1.
Yes, exactly. Does that make sense? Like, it's almost like you lose 4, but then someone gave you 5. So from the beginning, you basically added 1.
Yes, sir.
Fantastic. And thank you, Ayanda. That was awesome. Anati, let's go to you. Can you help us with question 4?
Sir, can you hear me?
Loud and clear.
Okay, I think the answer for negative 4 is 5x plus 7x equals 12x.
Perfect. I like that. So 5x and 7x are like terms. You add them
Yes.
together, you get 12x. What's
Yeah.
and the next part?
The next part would be 5y plus y, no, 4y plus y equals 5y.
Perfect.
The most.
Perfect. Okay. Now, I want to point out, guys, there's two skills that we've covered now. We've covered multiplying out or distributing brackets, and we've covered collecting like terms. So just before our break, we are going to put these into action in an equation question. Okay, so actually, let me go back for a second and give you a chance to take a picture if you need to. So if you need to take a screenshot, now is your chance.
Take a screenshot.
Okay. Take it if you need it. Because this is just the like term stuff. And now I just want to put that into use in an equations question, or at least start that process. So at the moment, we have 3 questions on the board. I want you to try and do these 3, bearing in mind some of the skills. Now, you don't need to multiply anything out here. I don't see any brackets, but I do want you to think about a couple of the rules. Can you collect any like terms? When you collect them, what processes or skills can you use that we spoke about earlier in the lesson to help us solve these equations? Okay. And even 10.7 is a little bit sneaky, but there are a couple of ways of doing it, but I want you to do the best you can. And then I will go through the answers for these. But I'm going to give you some time for that now. So over to my students. If you feel very confused, I would love for you to raise your hand or for you to put a question in the chat. What do you think, Yolanda? I think students are maybe not perfectly prepared for this, but they're close. I think they can give it a back.
Do it. Oh, I believe in my people so much. You guys can do this. You can do it. All the skills that Teacher Peter already taught us together and in one question. Let's do it, guys. Woo, some hands there.
Kanyesile, I'm going to unmute you for a question. And then I'll come to Tato next. What can we do for you, Kanyesile?
So I wanted to ask you if the lesson will be recorded.
It is recorded, yes.
Okay, sir.
Definitely. So Koketso's asked a very good question. Well, how do you work out 10.7? So if I go back to the beginning, Koketso, do you remember I said to you, you always try and isolate the variable. So in this case, what is the variable? I think the variable is the 7, sorry, not 7, it's this x over here. So I'd really like this x to be by itself. Now, the thing that's crowding out the neighborhood is the 5. Now, once I've got rid of the 5 in whatever way that is legal, I also have to deal with the negative sign in front of the x. So those are my hints. My hints are, look, we know we want to get the x by itself, but we have to use, we said inverse operations, and we have to always do the same thing to both sides. Okay, and I would start with the 5. That's my last little hint. Now zip.
Those were nice hints, guys. So we should do this. Come on, Koketso, do you wanna tell us about it? How did you solve yours? Actually, I'm interested.
There's actually more than one way to do this. There's, like, there isn't actually just one way.
Yeah,
I'll show you both ways.
Yes, guys.
Oh.
Wow. Is already on 10.8. Go Shoner, go Thailand. Remember, guys, to write it on your book so that you can check the corrections and mark yourself correct or wrong.
10.9 is a toughie. I'll give you a hint. If you had 2 x's and you wanted them to be combined into how do I get this back? Here's my highlighter. If only there was a way of combining these 2 to become one term. That's my hint.
Hint, guys. Got that hint.
I'm going to go through these questions. And, oh my goodness, I've seen something else. If only there was a way I could combine all these terms together. Are they like terms? That's the other thing I want to ask you.
Okay, so says his answer was 25, but he's just double checking for 10.7. You can double check.
I'm going to go through 10.7 now because it's actually a little bit sneaky, but if you follow the rules, you will get there.
I'm glad Lisette says she understands now.
I'm actually going to do 10.8 and 10.9 first, and then I'm going to do 10.7. So if anybody would like to give me the answer for 10.8 or 10.9, could you put your hand up? And then I'll do 10.7 last. So Onati, I'm going to come to you. I think your hand went up first. Can you unmute? Tell me, Onati, what do you need to do there?
For which one, sir?
10.8.
Okay. What I did, I first used the inverted the symbols into minus.
So did you okay, so did you not collect all the like terms first? You moved them around. Is that what you're saying?
Yeah, I moved them around, yes.
Okay, explain what you did. Did you take away 10 from both sides, basically?
Yes.
Okay, so you dealt with, let me see if I'm understanding this. You dealt with the 10, the 50, and the 20, and you essentially made them reappear on this side.
Yes.
Okay, so tell me if I'm saying it right. You take away 10 from both sides, and you get a minus 10 on this side. You take away 50 from both sides, you get a minus 50. And then you take away 20 from both sides and you get that.
Yes.
Okay. So I know I'm saying it the long way, but do you see how I'm saying you take away 10 from both sides, you take away 50, and then what was your final answer?
My final answer was 100.
Yeah, I agree with you.
Well done, Natty.
Now, what I was going to say, Onati, is what you could have also done is if you added up all the numbers at the beginning, and this is both ways are perfectly correct, you get x plus 80 is 180. And then if you take away 80 from both sides, and again, notice, guys, how I'm actually not writing the steps so much as I'm just doing it in my head. I'm taking away 80 from both sides. On the left-hand side, that means I just have an x. On the right-hand side, I just have a minus 80, and then the answer is 100. Okay, what about 10.9? Who can help me with 10.9? Whose hand is up? Ayanda.
Ayanda's hand is up.
Help me through 10.9.
Okay, sir. So with me, I said, since it will be x plus 50 equals to 180, so therefore, since 1 is going to be in front of the x's, I got 2 x's equals to 180 minus 50.
Okay, so I'm even going to break it into 2 steps. So your first bit was you realized that x plus x is 2x. Fantastic. And then tell us the next step.
And then I subtracted
50.
I took 50 from 50, and then I got what? Negative 50.
Okay, so I'm going to say you took away, you saw the plus 50 and you took away 50 from both sides, and that left you with this.
50, yes, sir. So
and you get 130, yeah?
Yes, sir. And then I divided, because I needed to leave my x by itself, so I divided x by 2 and 130 by 2, and then my answer was 65. X is equal to 65.
Now, this is brilliant. So your answer is definitely 65, and yeah, perfect. Thank you so much.
Well done, Ayanda.
So guys, what I'm going to do is I'm going to answer 10.7, and then we're going to take our brain break. actually, you know what? Let's do our brain break first, and then I'll come back. So what I want is I want everybody to stand up, and I want you to stretch. And Yolanda, if you could please make sure the students tell me who is doing the best cup of stretch. I'm gonna stand up and stretch too.
Let's do this, guys. Let's do it. Who's Bongile? I see you. I see you, girl. You're doing it. I see you.
Oh. So I want to see everybody stand up and stretch. I'm going to do some.
Can you see the stretch?
I'm going to do the high leg raise. Let's do it. Oh, do you remember
where I see you?
I'm having a flashback to grid classes at the gym when they make you do this. You know, like when they go the opposite arms and you. Okay, who's giving us the best stretch today? Who's giving us the most enthusiasm? I want to see it. Sibongile looks so cool. There's just nothing too stressed, just nice and smooth. There we go.
I see Busisiwe also. I really like Kanyisile's one.
There we go. Kanyisile, for me, that's 10 out of 10. 10 out of 10, for sure. That is the best one I've seen in a while. There's such rhythm there too. Like it's just.
No, that's my exercise for days. Thank you, Kanyisile.
All right. I hope that everyone has had their quick power up. Guys, I can't tell you how awesome it feels to stretch. I really like you're missing out. And it's so nice to see you guys getting involved. So
it's really nice. Yeah.
Okay, so today I've got a Teenage Mutant Ninja Turtle brain break. So guys, when I was growing up, this TV show was like, when I was a kid, it was like I don't know what the equivalent is today, what like Blaze and the Monster Machines, maybe, I don't know, whatever, was the main deal. So I have a soft spot for the Teenage Mutant Ninja Turtles. Anyway, go for it. See if you can solve this.
Let's do this, guys. I'm just hungry. Looking at that.
So one Ninja Turtle. Does anybody know? I mean, this is probably way outside your time zones, but what the name of this Ninja Turtle is? Like the orange one had a specific name, but you're right. This is 22, 22, 22. So
I don't know the name of this.
But I know you have to be like a real, wow, Bernita, well done. You nailed it. It's Michelangelo. Yes. They were named after Italian painters.
I didn't even know that.
They were Italian. They were named after Italian painters. Anyway, but that's a whole. I highly recommend it's a good comic show if anyone's interested. But now, guys, be careful because you have to figure out how much a slice of pizza is first. Because anything to get 0, yeah, be careful with that one. What do we get for the pizza slice? How much is a pizza slice?
Tandega guy says that the little Popeye over there, it's Mickey.
It's Mickey. So in the show, the Teenage Mutant Ninja Turtles really like pizza. That's kind of why there's pizza here, but yeah, that's a little bit. Okay, so the pizza slice isn't 0, guys. It isn't 0. So I think the pizza slice 22 divided by something is 11. I see Future has put it on answer, and a couple of people, Boykanyo has also said it's going to be 2. But then if that is 2, then what does, okay, so the red Ninja Turtle, bonus points for the red Ninja Turtle's name, has to be Raphael. Yes, yes. Oh, you guys know this show. Awesome.
I already pointed out and she didn't know the name. So she's like, the head is 0.
Yeah. So the head is 0. Guys, I can't tell you how happy this brain break is making me. This is like a flashback to my childhood. Like I love this is the best brain break ever. And blue was Leonardo. Yep. And then what was the last one? the purple one. Okay, so what's the final answer? It's going to be Benita Clono. I think I agree with you, Koketso. It's 24.
Well done, guys. Well done, all of you.
Right. Fantastic. Okay, let's go back and do a couple. Guys, that was pretty good. Well done. Let's go back and go through this one, and then we're going to do 2 more sets of questions, and then we're done for today. Okay, following my method for dealing with this, what I'm going to do is I'm actually going to take away 5 from both sides. So if I take away 5 from both sides of the equation, the right-hand side's 5 gets knocked out, but then I have to have a takeaway from 5 on this side. Okay, so again, in the previous lessons, I was literally putting the step in explicitly because I really wanted to kind of ram it into your heads that we're doing something on the same, basically, like we're doing this. Essentially, what I've done is I've done this, and I've said I'm going to take away 5 from both sides. But eventually, what you realize is you always knock out the one side. And so essentially what you get left with is 20 minus 5 on the left-hand side and minus x on this side. Now, this is where it's a little bit sneaky. There's a minus 1 in front of the x. What is the relationship between this minus 1? Let me put that in. There's a minus 1 here. Now, if the minus 1's relationship with x is multiplication, guys, what's the inverse operation to multiplying by minus 1? Can you put it in the chat? So I want to know what's the inverse operation of multiplying by minus 1. Remember, the number in front is multiply.
Let's go, guys. Let's
Who can help me with, okay. Woo. It's divide. So it's going to be, because it's multiplying by minus 1, what you're going to do is you're going to divide by minus 1 on both sides. So I divide by minus 1 on both sides. These cancel out, and we get x. And then on this side, my answer is going to be minus 15. Okay, so that was the one way of doing it. The other way of doing it was to move the minus x to the other side, which will come up in later questions. But for now, I just wanted to keep you on those ones. Okay, take a screenshot now if you need to. We're going to practice some more like that. Okay, let's move on to the next one. So I'm going to do the first one for you. And then what I'm going to do is I'm going to ask you guys to do one like this, and then we'll go from there. So what I would do, if I see a question like this, 10.10, there's a lot going on. And so I just want to make sure you see how the method goes. The first thing I'm going to do is I'm going to multiply out this bracket. And I get 6 minus 3x. So that's the one side. On the right-hand side, I look for like terms. If there are any like terms, what I'm going to do is I'm going to put them together. And what I've spotted, guys, is that there's a 4 and a minus 27. So I'm going to simplify them by adding them together. So the 3x stays by itself. But now I've got to think, what is 4 minus 27? And 4, take away 27. Don't be afraid to use your calculator if you have to. It's going to be minus 23, but I can even check. I get minus 23. Okay, now we have a little bit of a problem compared to before. But first I want to make sure that you can see that where I got those numbers from. We've never had this before, but we've got variables on both sides. And so what we need to do is we need to move all of the numbers to one side and all of the variables to one side. And so what I'm going to choose to do is I'm going to first move my minus 23 across. So if I do that, what is the opposite operation of minus 23? I'd love someone to put that in the chat. What's the opposite operation? It's plus. Okay. So what I'm going to do is I'm going to add 23 on the one side, and I'm going to get left with a lonely 3x. But then on this side, I have 23 plus 6 minus 3x. Now, guys, notice how my minus 23 reappeared on the other side because I added 23 to both sides. Okay. Now what I want to do is I want to move this minus 3x. Now this is minus 3x. What is the opposite process? If you think of the whole term, I want to move the whole thing. If I'm taking away 3x, what is the opposite to taking away 3x as an operation? I'd love someone to even maybe unmute as well if they want to talk us through this, because this is such an important idea. I've just gone all yellow. Okay, it's plus.
You can raise your hand also, guys, if you want.
If you want to, I'm going to quickly turn my
chats. Well done.
Okay, so if I add 3x to both sides, what's going to happen is, let me actually do this. So the 23 and 6 is 29. Now, if I add 3x, the left-hand side is no longer going to have 3x, but the right-hand side is going to have another 3x. So I want you to just take a moment and see if you understand that. I'm adding 3x to both sides, which gets rid of the negative 3x on the left-hand side, and it gets me that. Okay, now the last step is to get what is 3x plus 3x. It's going to be 6x. And now I need to deal with this plus, well, not plus, this multiply 6. So what's the opposite of multiplying by 6? It's going to be divide by 6. So I do that on both sides. And what I'm then left with is I've got x on the one side, and then on my calculator, what's 29 divided by 6? Or I could count it out. It's just going to be 4 and 5/6. Or as a decimal, it'll be 4.83. Okay, so to finish today, all I want you to do, guys, is I want you to attempt question 10.11. I don't want you to worry about 10.12. I just want you to try and do 10.11. And we are going to carry on with this type of question in the next lesson, but I just want to give you a chance to give it a go. Do you cancel out the 6s? Owen, you're quite right. These 6s cancel out, and that's why I get left with this x. So if you look here, this x is all of a sudden all by itself. And the reason is you knocked out the 6s. And then when we take 29 divided by 6, that would be the final answer if I left it. So I could say x is 29 over 6, but I've converted it to a mixed number. So let me even go back through the steps. So this first step was multiply out. Then I had to collect like terms. Then I took away 23. Well, no, sorry, I added 23 to both sides. Then I added 3x and then to both sides, and then I divided by 6. Okay, so everyone is doing 10.11 just to finish off today. And that's going to be our last question. We'll carry on with the stuff in the next lesson. We've done a lot today. And then can you see the question?
Yes, they can see. I just ask everyone to put thumbs up if they do understand the 10.10.
Okay.
Cool. So far, so good. Okay.
So what I want is just take a screenshot of this working out for 10.10 if you can, because I'm going to talk a little bit about 10.11 in a little moment. So just to give you fair warning. And then, Kanye Celia, I'm going to unmute you. What's your question? Yes.
So I wanted to ask, is today polls day or quiz day?
Poll day. We're going to do polls in a moment. I just want to finish this question with you guys. Okay.
Amahle, you are more than welcome to ask questions, or you can just direct message me. Okay.
So for those who are doing it, the first step for 10.11 is to get 6x minus 15 minus 12 is x plus 7. So that's the very first line. And then I want you to think, can you neaten up one of the sides here? Maybe you can neaten up one of the sides. So what I'll do is, I'll work through this example with everyone now. I would love everyone to tell me what's their next step. So given what I've got, I've multiplied out. What do you think the next step you would need to do? I think it would have to do with this over here. And so if we have minus 15 minus 12, I think we get 6x minus 27. Yes, exactly, Scarlett. I completely agree. Now, guys, the next step that I'm going to have to deal with is I want to get all my variables on one side and all my numbers on the other. And so I'm going to do the opposite of minus 27. Tell me in the chat, what is the opposite of minus 27? What's the opposite operation of minus 27? I'll give you a moment to get that. Yeah, you add 27. Exactly. So if I add 27, I'm going to get 6x equals x plus 7 plus 27. And now the last thing that I need to deal with, sorry, that was enormous, is this x. And this is a plus 1x. So what am I going to need to do to deal with this plus 1x? What do I need to do with the plus 1x? I think I need to take away x from both sides. And if I take away x from both sides, I'm going to get 6x minus x, and then the x that was there is going to get knocked out. And because I got 7 and 27, I get 34. And then I have to say, what is 6x minus x? It's going to be 5x is 34. And then I need to deal with this 5. What do I need to do with this 5, guys? Who can tell me what the last step is going to be? So it's multiplying by 5 at the moment, but I need the opposite operation. Pop it in the chat if you can. So all we need to do is I need to divide both sides by 5. If I do that, the 5s cancel out, and my final answer will be 34 over 5, or if I count up in 5s, it's going to be 6 and 4 over 5. Now, everyone, I definitely pushed you a little bit further today. We will be repeating similar questions like this in the next lesson. So if you are feeling a bit unsure, please, I really recommend come to the next lesson where we'll get even more practice. Today was like we were expanding your minds. Okay. Can you please, Yolanda, send the students the poll? I would love to get a sense from the poll of how things went today. And then remember, we will practice this again in the next lesson. Okay.